Hi everybody, it's meteorologist Joe Chaffee. Today we're going to take a look at probably a map that you could be most familiar with, or at least of all the weather maps that are out there. This one is one that gets the most play in a simplified version, and that's the surface map. The surface map is the most important map from the standpoint of the day-to-day weather because of the fact that, well, we all live at the quote surface. So we're going to show you what the surface map is, how it works, and how to interpret some of the numbers that you see. And you can access these surface maps, by the way, if you go to the Weather Service's website, wpc.ncep.noaa.gov, and you'll see there's a link for surface analysis. They have a wonderful tool that you can use to pull up the surface maps, which are plotted every 3 hours, and then you can kind of go ahead and take a look at what's happening. And here's an example of a surface map for the United States, and ultimately it's about the data that's collected, and from the surface map you're going to be able to see where all the fronts are and where the low pressures and high pressures are located. So how do we get a surface map? How do we create one? Well, it starts off with the data, and the airports around the country, every hour they take observations, and sometimes they take observations more than just once an hour, depending on whether there's some weather going on. And we just plot them on a map. The numbers that you see here, and I'm going to highlight a couple of them. But we'll take, for example, this observation right in here. So what is that observation telling us? The top number there, that 51, that is the temperature. The two little dots, that is precipitation type. So the two dots symbolize rain. If you had a three dots in the shape of a triangle, it would be moderate rain. If you had 4 dots, 2 going across and 2 going up and down, that would be considered heavy rain. The bottom number, the 49 that you see underneath the wind barb, is the dew point. So we can calculate the relative humidity when we have the temperature and the dew point. The wind barb, which is the direction of the wind, and the speed with the little stick that sticks out of it. So we've got a west-southwest wind at 10. That it looks like that's a long bar, so that's a 10 knot wind. And then what I regard as the most important number in terms of the plot, and that is going to be this number here, 153. That is the measure of pressure, and it is in millibars, leaving out the 10. So it's actually 1015.3 millibars, and these figures are all plotted on the map. These observations are all plotted on the map, and then we just pretty much connect the dots. So we're going to run, so this pressure here is roughly 1016, okay? And you can see, by the way, off to the left of the red circle I drew, there's a 1020. So that's the 1020 millibar pressure. So in the process of connecting the dots, you wind up with the isobars, the lines of equal pressure. And then you construct a map that shows you where you've got the highs and the lows. There are your 2 lows on this map, one that's off the coast of Maine, another one south of James Bay. And by the way, when you analyze these maps close up, when you start looking at the temperature profile and the wind directions, you can figure out where the cold fronts are. So if you look in Pennsylvania, there's a cold front that cuts through there. Sometimes the temperatures on either side don't really reflect too much of a change in air mass. You have to probably go a little bit further to the north and west, and sometimes the changes are more extreme. But in the east, for example, here the front is determined by the fact that most of the winds ahead of it are from the south-southeast, and behind it here, behind the front, the winds are from the west. But this is one of those situations where the temperatures actually behind the front can wind up being a little bit warmer than the front than ahead of it, because you've got an ocean wind here, so there's a marine layer to get through. But where it becomes a bit clearer is, for example, when you go into some of the warmer climates to the south. Now here's where it's a bit more obvious, where you've got the front and southwest winds ahead of it in Georgia, for example. This is a morning map. You would see larger differences between the temperatures on one side of the front to the other if we were to look at a map from the late afternoon. So here we have temperatures, for example, in the 60s, winds from the southwest, and a low analyzed in western South Carolina, and a trailing cold front, because on the other side of that front, all the winds are from the northwest. And you'll notice that as you go north and west of there, you start to see these temperatures drop 50s, 40s, 30s, and 20s. Okay. Whereas the temperatures ahead of the front are fairly uniform. They're all pretty much in the upper 50s to lower 60s. Now, when you look at a map, say on Tropical Tidbits, and I've brought this one up. This is a NAM surface map. I'll bring up the GFS because it's a little bit easier to see the isobars and everything else that's going on. So when you see this particular map that I use every day on my live streams, you've got isobars, you have the lows and highs, although it doesn't show up much on this particular view. Let's see if I can advance it a little bit, but there's your high, and there's a low coming out, running out to Tuesday. And on the map itself, the green area on the GFS is actually measured rainfall in tenths of an inch. The darker greens, you can see the scales on the side. The blue is snow. The darker blues are heavier snow. And again, you would use the legend on the side to determine what it exactly means in amounts. But the most important thing here is that you see where the isobars are, and you can figure out where the highs and lows. And by the way, when you read this map, just to show you, if you want to, so you know what time map you're looking at, if you look up at the top of the screen, you'll see underneath where it says GFS 6 hour, initialized 6Z. So the times that are used on these surface maps, Greenwich Mean Time. So if you're in the eastern part of the United States, you need to subtract 5 hours from Greenwich Mean Time. So for example, 6Z, 6 a.m. Greenwich Mean Time would be 1 a.m. Eastern Time. And the reason it's done this way, it's Greenwich Mean Time, so everybody across the world is on a uniform time when you're looking at these maps. Otherwise, it would be crazy if you had to do all these maps based on different time zones. So you draw one map, you pick one standard time, and everybody kind of works off of that with regards to what the maps are going to look like. And it will tell you that this is the model run from February 8th, 2019. So this was from overnight. The forecast hour is 90 hours out into the future, and it's valid at for 0Z, Tuesday, February 12th. 0Z is 7 o'clock Eastern Time, Greenwich Mean Time, midnight. And by the way, when we go to daylight saving time, then it becomes a 4-hour difference. So and weather folks don't really care for that, because then it pushes the model run cycles back, pushed out further ahead an hour. So we have to wait an extra hour for the European model when it comes out, and an extra hour for the NAM model. But this is just how it goes. All right, so that pretty much covers it all with respect to the surface map. Look for more instructional videos that I'll be coming out with in the next several days or so. We'll be adding to the collection. We'll be starting to do some stuff with the upper air. We'll take a look at a few other maps that are available out there that might be a little bit technical, and we'll take them all apart for you. And if you have any suggestions regarding something that you might want to know about, just put something up in the comments section, or perhaps you can just send me a message via email or to my Facebook page, Meteorologist Joe Chaffee, or to Twitter at Joe Chaffee. And one other thing, for those of you who are interested in a more complete weather experience, I do have a subscription platform on Patreon. It's just $2 a month. And you can also download my free weather app, which is available for all mobile devices, Android and iPhone. So go to your respective stores, download, and enjoy. And from there, you can access the link to my Patreon page if you're interested. That, again, is the subscription one. That's $2 a month. But the app is absolutely free, and you can use it anywhere in the U.S. because you can put in your own location and get your own local forecast on top of all the other stuff that I'm doing. Have a great day, folks, and we will see you soon.